Hello, people. This is the homework for lab number 2, and it's the morning session that I'm going to prepare this video for. Uh, the problem that we have to do is actually from a previous midterm. So here's the situation: you're given this configuration, and you are told that the ends of that top pieces are clamped. And the middle point of this horizontal piece is being pushed down by a thousandth of an inch. You're asked to use symmetry to reduce the model as much as possible and use the most appropriate element. As soon as you see this, you should realize that this needs to be done with beam elements, not with solid elements. Do not go and try to create a three-dimensional drawing where you draw the line and then pad it, etc. This has to be done with beam elements, and therefore all you need is the wireframe. Wireframe means a line. That's pretty much it. Now, when you look at this problem, first of all, you don't know what the force is to pull this thing down. That much we know. We also know that because of the nature of the problem and the loading, this has a plane of symmetry which is xz. So do not model the whole thing. Model only half of this, which means that you're cutting it with the xz plane. And that's how you do it for the test and for this homework. However, after I've done it like that, I will come back and show you how to do the problem if you were not expected to use all applicable planes of symmetry. Okay? Very important. First, I'll do it the way I want you to do it for the homework and for the test if it's given to you, and then come back and show you how to do it with the entire model. Okay? Good. So let's go ahead there. We start the part file. Immediately we save it. So I'm going to go File, Save Management, Save As. On my desktop, a new folder, and the new folder is Lab 2, Homework. This is obviously morning session, morning. Okay, so everything is going to go there for this particular problem. Okay, now in the class I told you there are different ways of creating this wireframe. Because this present problem, this entire thing lies in a single plane, for example, something parallel to YZ or YZ, I can do that as a sketch, okay? I can do that as a sketch. But remember, if you do it as a sketch, you have to come back and join it. Do not forget to join. We'll do that. On the other hand, you can also do this thing in the space as a line and another line, etc. So that is the other option to do it. We have done both ways in the class. I'm not going to do it here. This particular problem, I'm going to do it as a sketch. If you want to have more practice, go and look at the homework number 2 for the afternoon class, where this structure is not all in the same plane. So there you have to go and create the wireframe in the space. All right, let's go ahead and do that. I will model only half of this, okay, instead of modeling the whole thing and then trying to cut it, stuff like that. So on that vertical plane, I will sketch this thing that essentially is half of that geometry that you see there. Okay, now I noticed that, for example, inadvertently I put this thing to the left of that. That's okay, I'll fix it. That point, control this point, I'm going to make it coincident, etc. All right, let's go ahead and put some dimensions here. So let me see. This is 3 inches. Okay. This is 6 inches. All right. And this is also 3 inches. 3. Okay. Very good. Now the reason that these are white, because this is not fully constrained. I really don't care as long as you do the problem. I don't insist that everything be fully constrained, but anyway, that's what it is. So exit. Now this is generated in a sketch. In order to be able to do this thing with beam elements, you have no choice but to join that sketch. Otherwise, you won't be able to mesh it. And I want to remind you how we did the joining. The joining cannot be done in part design. You either have to do it in generative shape design, or you can do it here. So start mechanical design all the way. Let's see now, third from the bottom, wireframe and surface design. This wireframe and surface design is the baby version of generative shape design. For the purpose that we have in mind, we can do it here, but I rather take you into the generative shape design. Okay, so we go here to let me see now. Can't remember. Hang in there. Under shape, yeah. Shape workbench. The let's see now, the fifth one from the top, it says generative shape design. You click on it, and all you need to do is to get the operations toolbar. This is the operations toolbar, and the one on the very left is called join. You have to do that, otherwise you won't be able to mesh this thing with beam elements later on if it's done in a sketch, and it is done. You click on it, and you select that sketch, and that's pretty much it. That's it. So nothing else you need to do here. Now we can go to the part design if you want and apply material, or we can do it here. It really doesn't matter. So what I'm going to do is I'm going to do it right here. Apply material. This is made out of steel, and I apply it to the part and close it. There we are. We save this thing, click on the floppy, and then we're going to go to the usual analysis and simulation, generative structure analysis. You click on it. It is a static analysis that you're doing. And remember, I told you that if you accidentally delete this line static case until you put it back in as an insert. Okay, now I don't have it here, but let me do that. Okay, let me on purpose delete this for you. I don't want to do that, but on purpose I'm going to do it. Then what you do is you can always say insert static case. Now the reason that I can't do it right now is because I haven't meshed it probably. That's what it is. So undo this. Okay, just be careful not to delete this. Okay. So first thing we're going to do, we're going to mesh it with beam elements right there. So under tool manager, where the traffic light is, under the model manager where the traffic light is, you expand the icon to the left and you use beam element. Remember, CATIA, when it sees a solid object, it meshes it with these elements. There is no solid object, you have to do it yourself. You click on it, you select this, and notice that it selects the entire thing because we joined it. And let's put down, for example, now remember, this is 3 inches. So let's make it, how about maybe a point, I don't know, 0.2 inches. So it's going to put 5 elements here, I don't know, 5 elements there, 15 elements there, etc. So I'll put down 0.2. Okay. These beam elements are so robust that really how many you use is not that critical. You say, okay. Now, would you like to see the mesh? The usual thing, you put the cursor here. Notice that the beam element is created, but it doesn't show it to you. Right-click, mesh visualization, nothing fancy. okay, if you put the cursor, you see that there's going to be element numbers and node numbers. The one in the middle of everything is like, let me zoom in further. So this is element number 36 going between node 39 and 38, etc. Nothing fancy. Deactivate this. The next thing is we want to put a cross-sectional area. Now, cross-sectional area, because it's circle, you don't need an orientation point. Now, how do we do this? This is the 1D property. See that? In the model manager, 1D property, you click on it. It says, okay, what is it that you want to put cross-section on? We select this, and because it was joined, it's going to put the same cross-section on all of them. It's a cylindrical beam that I want. Click on the wrench and put down 0.1. Now notice that the cross section of these two pieces is different from that. So the radius here for these two pieces is 0.1, and for this piece is 0.2. Okay, 0.2. So the way we are doing it, we put the 0.1 on everything, and then we come back and make a change for this bottom one. Okay, so 0.1 on everything. We notice that we can close it, by the way, because this is the cross section is a cylindrical circle and there is no orientation point needed. We say okay. And if you zoom in, you can see the circle right there. And it's the same size circle. However, we know that this has a different cross section. The radius is 0.2. So how do we do that? We put the cursor, open up the properties toolbar, the properties branch right there, properties branch. Put the cursor here on the 1D property, right-click, towards the bottom, at the very bottom, it says local 1D property. You click on it, it says, where is it that you want to change? It's this piece that I want to change. And what is the radius that I want to give it? I want to give it the radius of 0.2. There. So now you can see these two pieces, this one and that one, have radius 0.1, and this one, because we changed it through the local 1D property, has radius of 0.2. Don't let this thing bother you, because this is what we put there initially, but then we went and changed it, and it put these things there. Very good. Save the analysis before we run ourselves into trouble in case the power is lost or in case we have to kill the job. So we go File, Save Management, Analysis, Save As. In that same folder, Lab 2, Homework Morning, Analysis 1. Very good. Now, we are told that this point is clamped. So click on the clamp, select that point. Okay, that much we know. We know that this point is on a plane of symmetry. Now, if it's bothering you, I can always hide these properties right there, local property there. So this point is on the XZ plane of symmetry. That means no displacement in Y and rotations exactly the opposite. So let's go do that. So we click on this. Okay, and on purpose, let me uncheck all of these. On purpose, I'm going to call this symmetry condition. Okay, symmetry condition. You'll see, because this is going to help me to identify something later on. Symmetry condition. So no displacement in Y and rotations opposite. So opposite means that if these are unchecked, they're going to be checked now. Obviously, this one is checked. This is going to stay. This is symmetry condition for beams. We say, okay. Then I want to take that same point and pull it down by a thousandth of an inch. So in order to remember, in CATIA, if you want to give it a non-value for displacement and force displacement, first you have to make it 0, just so that I don't mix these up, because this one is for symmetry, just so that I don't mix these up. First thing, I'm going to select that same point, and say displacement in the direction z equal to 0. And on purpose, I'm going to call this thing pulling down. You can see that. I don't want to mix these up because it's recipe for disaster. You say, okay, now I go and change this thing to 0.001. So go to the enforced displacement in the loads toolbar right there. In the loads toolbar, you click on it. It says, where is that thing that you want to change? I go and select the pulling down, and I put down negative 0.001. Okay? Negative 0.001. We say okay. Save this and run it. Nothing fancy. Let's look at the view from the front, by the way. This is a 2D problem, so anyway, look at the front. Look at the deformation. Yeah, you expect something like that to happen, right? Yeah, because this is on a symmetry plane, it doesn't go to the left or doesn't go to the right, etc. If you want to know the values, click on it. Notice that we applied 0.001 here, right there. And then the other ones, if you want to change the color, rendering, you go average ISO, and there we are. Okay? Now, remember, in CATIA, you cannot display stresses. You can display the principal stress, and the only principal stress that it will give you is the axial principal stress, which is kind of useless for bending purposes. You see that? It'll give it to you. It'll give you one component of stress, and it's going to be the axial one. Okay? Yeah. Good. The rest of it is here. Notice that this one has pretty much, let me see now. This one has a, very small axial stress. See that? Now, mainly because it's thicker, right? It's a thicker beam. Let's deactivate this. The last thing is, remember, this was a test problem. We gave you a box like that and says, write down your answer in the box. What is the force needed to pull this point A down by 1,000ths of an inch? You have to write the right number here. Now, so we go put the cursor on the sensor. We go to the second last, and then reaction sensor. It says, okay, where is it? Well, it's the pulling down thingy, right? And you say update, and you're going to get a point, almost half a pound, 0.496 pound. So first of all, don't cancel this because I will not be able to see that. Let me show you. Cancel it. It's not going to appear here. Let me try it again. Right click, reaction sensor, pulling down, update, 0.496. Say okay. Don't cancel. Now, because when I mark your paper, I can go here, double click on it, and find out where you got your number from. Now, the number that goes in this box is not what's there. It's double of what's there. So you can write 2 times 0.4, whatever it was, 2 times 0.469 or 96, I can't remember. But anyway, that's going to be the answer that goes in this box. All right? 5 points. That's a lot, right? Good. So let's save this thing. Because I want to go and repeat this problem for you, except that I will not use symmetry. On the test, you have to use symmetry. It said use all applicable planes of symmetry. Okay? So here's what I'm going to do. First of all, I'm going to kill this job. I keep this though. Okay? So what I'm going to do is I'm going to go to on purpose, I am going to actually redo this. How about that? Yeah, on purpose. So as a matter of fact, let me delete this join. Let me go to the sketch. There's my sketch. And on purpose, I'm going to draw that as a full line, okay? So make this thing 6 there. And I do the rest of this. The rest of this I can just mirror. So this line, control that line. Control that line. I'm going to mirror it. Let's see if we can find the mirror. Is this the mirror? Yeah, mirror it with respect to that. Because I'm just too lazy to do it. Now notice that the reason I actually extended this line, I didn't want to break there, is because I don't want to have a point at that location. Okay? That on purpose complicates things a little bit. If I had done just mirror of everything, including that piece, then there would have been a point here that I could have used later on. But on purpose, I got rid of it. Exit. Okay. Let's join it. Still have to join. Material is already there. Okay. Now, for a reason that may not be obvious to you, let me create a point exactly halfway between these two. Okay, a point on this curve, exactly halfway. So I'm going to create a point, and the way I'm going to do that between this point and that point, exactly middle point, and there we are. That may not be obvious to you, but you'll see why in a minute. So now we're going to go to generative structure analysis. Okay. And mesh it. Mesh this. Because we joined it, everything is going to be meshed. And we say, okay. Now, if I double click on that, if I double click on this, the problem is that this point may not have been a node. You know, like I put a point exactly halfway between these two on that line, okay? But there is no guarantee that this point is going to be a node. Now, there are different ways of doing this, fixing this. One of them is the following. Let me cancel that, okay? And so notice that although I have meshed this thing, let's look at this thing again. There is no guarantee that this point is one of these nodes. In fact, to convince you, let me do the following. Let me go and display the part. And I'm going to hide this line. If you go close enough, and you put the cursor there, it just happens because the point this point was exactly in the middle. There seems to be a node exactly in the middle. The problem is that this point is not a node. It's just a literally geometrical entity. So here's what I have to do. If you want to make sure that this point is a node, unfortunately, you cannot do it in generative structure analysis. So what I'm going to do is I'm going to delete my element right here. Delete the element. Okay? So you have to do the meshing not in generative structure analysis. You're going to go to the advanced meshing tool. You'll see why. Where is my, let me just display my joint, by the way. Let me just display this so that you can see what's going on. There we are. Okay. So I go there, and there is this icon here, which just looks just like the one that we use in the generative structure analysis, right there. You click on it. Notice that there is more options down here. More options down here. I can select that join, no problem. But then I'm allowed to add a point so that it becomes a node number. becomes a node. So I'm going to click on this. See that icon? See this? You click on it and it says, okay, where is that point that you want to include it in your mesh as a node? So it's right here. I am guaranteed that there's going to be a node there. Guaranteed. Good. And then say okay. The rest of it is just like before. You go back to the generative structure analysis. That's what advanced meshing tool is, doing things that cannot be done for meshing purposes in the generative structure analysis. What's the rest of the stuff? It's identical. So I'm going to put, first of all, 1D property on that entire thing. Remember, it was radius 0.1. Okay. And then I'm going to put the cursor on this line, on the properties line, right there. Right click, local 1D property. And I'm going to select this line. Now the radius is 0.2. It remembers these things because we already did the problem once. Say okay. The rest of it is this point, these endpoints. I'm going to clamp, and clamp. Notice that I don't have to worry about symmetry condition here. We don't have to do that, but we have to give it a downward displacement. Okay, so let me do the following. Let me hide this. Hide the property so that it doesn't block my view right there. And I'm going to hide this. Well, I can leave that point there because I'm going to have to pick it. And once I pick it, it knows that it's a node. Okay. So first of all, user defined on that point in the direction Z. And then I'm going to change it just like before. So there is enforced displacement. You select this in the downward direction, 0.01. Let's run it. Oh yeah. Oh, you know what? Let me see. I must have forgotten something here. Acquisition of field failed. Could not find any property. Let me see now. Did I not? Oh, property. I remember. I deleted it instead of hiding it. Damn. Sorry. Let's do it again. So 1D property right there. That's the first step. Remember? And then put the cursor there. Right click. Local 1D property. That line. And it was 0.2. Good. What I did accidentally, instead of hiding it, I said delete it. That's why I said I can't find it. I can't run it. So let's go ahead and run it now. It'll be fine. Done. Let's look at the view from the front. It's easier to see what's going on. Deflection? Yeah, right. Numbers? Yeah, 0.001, right? The force. Now let's go check the force. Put the cursor there. Right click. Create resultant sensor. Reaction sensor. And it's this guy that we put in there. Remember, we made it 0. So you select this and update. I better get 2 times 0.469, about 9. There we are. So I hope you're convinced that even it can be done without planes of symmetry. It's more work, okay? But remember, on the test, unless otherwise stated, you are expected to do all applicable planes of symmetry. Okay, that's it. Now I suggest, if you're in the morning session, I suggest that you also watch the video for the afternoon homework. They're different. And the thing is not in the structure, the frame is not in the same plane. So you have to create points and lines and things like that. Good luck.